How LIGO hears the universe right now. Space looks silent. No sound, no movement, no vibration. But in reality, the universe is constantly shaking. Not with noise, with ripples in space and time itself. These ripples are called gravitational waves, and humans built a machine sensitive enough to feel them. It's called LIGO. More than 100 years ago, Albert Einstein predicted something strange. He said space and time are not solid. They behave like a stretched fabric. When massive objects move, like neutron stars orbiting or black holes smashing together, they disturb that fabric, just like throwing a stone into a pond. But instead of water waves, the universe makes space-time waves. The problem was, by the time those waves reach Earth, they are unimaginably small. They change distances by less than the width of a single atom. So how do you detect something that tiny? LIGO stands for Laser Interferometer Gravitational-Wave Observatory. There are two main LIGO facilities in the U.S., one in Louisiana and one in Washington state. They are built far apart so scientists can confirm signals and ignore local noise. Each observatory is shaped like a giant L. Each arm is 4 kilometers long, and inside those arms is almost perfect vacuum. No air, no dust, nothing to disturb the light. At the center of the L, LIGO fires a powerful laser. That laser beam is split into 2 identical beams. One goes down one arm, the other goes down the second arm. At the end of each arm sits an ultra-perfect mirror. The mirrors are polished so well that imperfections are smaller than a nanometer. The beams bounce off those mirrors and race back to the center. Normally, both beams travel the same distance. When they return, they overlap. If nothing happens, the light can't show any change. It means space is calm. Now imagine a gravitational wave passing through Earth. It doesn't push objects. It stretches space in one direction and squeezes it in the other. So one LIGO arm becomes slightly longer. The other becomes slightly shorter. We're not talking millimeters, not microns, not even atoms. We're talking changes thousands of times smaller than a proton. Yet LIGO can measure it. Because one arm changes length, one laser beam takes a tiny bit longer to return. When the two beams recombine, their light pattern shifts. That shift is the fingerprint of a gravitational wave. It means space itself just moved. But LIGO doesn't just listen blindly. Earth is noisy. Cars drive. Winds blow. Oceans shake the planet. People walk. So LIGO's mirrors are suspended on multiple layers of vibration isolation. They float like objects in space. The system removes earthquakes, traffic, and even thermal noise. So only the universe is heard. In 2015, something historic happened. LIGO detected its first gravitational wave. It came from 2 black holes colliding 1.3 billion light-years away. When they merged, they released more energy than all the stars in the universe combined, for a fraction of a second. By the time it reached Earth, the signal was tiny. But LIGO felt it. Humanity heard the universe for the first time. Since then, LIGO has detected black hole mergers, neutron-star collisions, cosmic explosions in deep space. Each signal is like a heartbeat from the universe's past. What makes LIGO special is this. Telescopes see light. LIGO feels motion in space-time. It doesn't look at the universe. It listens to it. So when people say space is empty and silent, that's not true. It's full of invisible waves passing through your body right now. And somewhere in the US, a giant laser machine is quietly measuring the shape of reality itself. LIGO didn't just confirm Einstein. It opened a new sense for humanity. Not sight, not sound, but the ability to feel the universe.